Okay, use the Maclaurin series for cosine to estimate the value of cosine of 1/2 and determine the accuracy of the approximation. This is missing some information here. Use the Maclaurin series, it should say polynomial of degree 6. Okay, degree 6. To estimate the value of the cosine of 1/2 and determine the accuracy of the approximation. So remember that the cosine function is equal to 1 minus x, this is approximate, is approximately equal to x squared over 2 plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. In other words, this is a way of saying the Taylor series of the 6th degree of x. That's another way to say this. So now cosine of 1/2 is approximately equal to Taylor series of the 6th degree at 1/2, which is equal to, and basically we're going to take 1/2 and substitute it into x. So 1 minus 1/2 squared over 2 plus 1/2 to the 4th over 4 factorial minus 1/2 to the 6th over 6 factorial. And let's compute what all of that is equal to. Okay, so I get this is equal to 40439 over 46080, and in a decimal approximation this is like 0.877582, and there's some more decimal places that we could calculate there. This will be a repeating decimal for sure, because this is a rational number. Alright, so that's the approximation of cosine of 1/2 using the Maclaurin series with a polynomial of degree 6. Now let's look at our error, and we're going to use the Lagrange error remainder, or the Lagrange error bound here, and say that, you know, applying just the theorem that we talked about before, so the Lagrange R of 6 here is equal to the n plus 1 derivative, so the 7th derivative, okay, of some number c that we don't know, over n plus 1 factorial, what we had up here, n plus 1 factorial. N in this case is 6, so this is all over 7 factorial, times x minus a. So x is 1/2, because that's what we're estimating. A is 0, because this is a Maclaurin series, so the center is at 0, to the n plus 1 to the 7th. Okay, so the Lagrange error bound tells us that the remainder of 1/2, I should say, of this particular Maclaurin series is equal to this for some point c, where c is some number between x and a. So between a in this case was 0 and x was 1/2. Okay, so now how do we find an upper bound for this term? So that's the key here. Well, remember that f of x is equal to cosine. That's what we're starting out with. Okay, and if we keep on going, f prime is going to give me sine of x, or negative sine of x, excuse me, and then f double prime is going to give me negative cosine of x, and then f triple prime is going to give me positive sine, and then f quadruple prime, or the 4th derivative, will get me back to cosine. So this will be my 5th derivative, this will be my 6th derivative, and back here will be my 7th derivative. So the 7th derivative of cosine is in fact sine. So we can keep on going and say r of 6 of 1/2 is equal to the sine of c over 7 factorial times 1/2 to the 7th power. Okay. But you see here that sine is always a number between 0 and 1. So sine of c, let's look at the absolute value of the sine of c, is always equal to some number between 0 and 1. Okay? So we can say that the absolute value of the error, which is what we're really interested in, is at most, we can take this out and replace it with 1. 1/2 to the 7th times 1 over 7 factorial. So this is at most 2 to the 7th is 128 times 1 over 7 factorial. Let me calculate what that is. So all of that is 0.00000 1, 2, 3, 4, 5 zeros 155009. Okay, so this is quite amazing. It says that this estimate here of the cosine of 1/2 that we did using this polynomial, this completely untrigonometric function, this polynomial, is in fact our estimate is about 0.877582. And we don't know what the exact answer is, but we know that this number must be no more farther away than this much from the exact solution. So this is an incredibly really good estimate, and all I did here was use 1, 2, 3. Well, I went to the 6th degree polynomial, but I went to 4 non-zero terms, and it was able to give me this function. I could calculate most of this in my using some mental math without a calculator, with a basic grocery store calculator that just does addition and subtraction. I can estimate the cosine value of cosine of 1/2 within a really close approximation of the actual answer. Okay, so the Lagrange error bound here, or Taylor's remainder theorem, is something quite powerful in mathematics in terms of doing incredibly good approximations. Alright, let's end this here. We'll start another video with another example for you to get more familiar with this.